Hello everybody, my name is John Kenny and I'm the Technology Manager for Keysight's Power and Energy Division. I'm here today to talk to you about the E36100 family of power supplies. Now in a previous video, we talked about some of the features and benefits of these products for use on your R&D bench. But a lot of people have asked me, how did we do it? How do we get such a small, compact, quiet, precise, easy to use product in this kind of a package? Well, I'm going to show you a little bit about what we've done to make this product what it is today. And in order to do that, I got to take the cover off. So start off with, this is our main board. This is the power regulating circuits. And the first thing you'll notice is we have a very small heatsink. That was critical. We didn't have a lot of space in the box to fit the heatsink. Plus, we knew to keep it quiet, we didn't want a big fan, we didn't want a lot of noise, we didn't want a lot of heat generated, because frankly the heat makes the product less precise as it heats up the parts and makes them drift. So it was really critical to get this to be small. Now the question is, how did we do that? We use a hybrid technology of linear post regulation, and we went back in the old days. There was a technology called SCR pre-regulation, and we actually brought that forward and modernized it using MOSFETs and custom control to realize a very efficient, dense power mesh that doesn't generate a lot of heat. This heatsink has roughly a third of the heat of a full linear power supply of the same output rating. It also lets us use a very small fan, which is quiet and very efficient, and that's really the key to getting the heat down and keeping the size small. Now, the next thing we did was, you'll see here, this large donut-shaped transformer. This is a toroidal transformer, commonly found in linear audio amplifiers for consumers, and it's become readily available now for use in the power supplies. So you can see this is very small, very dense. It's the smallest and densest you can get for this much power. So the next thing I wanted to talk about was, we mentioned in the previous video about LAN and USB. That is in the back here on this processor board, and in order to realize that, we had to have a really small microcontroller, and it all fits in a single chip. And this is the first implementation that we're aware of that anybody has realized a complete LXI and USB power supply in a single chip processor. And that kept our heat down, our size down, and a side benefit of it, which we didn't expect, was it makes the power supply really fast. When everything's inside that single chip, it actually goes really fast. So this is one of the fastest power supplies we've actually made that's this low cost and this small. It's really great on the bench for that reason. Now, another point we wanted to make was, if you make products really dense and they get hot, if you make them too dense, you can get reliability issues. So we were very concerned that when we made this product this dense, that we didn't make it too unreliable at all. We wanted to make sure it was the best. So we studied reliability and what causes it, and we found that a common cause of failures was cables coming unseated. So in this design, we've used all the old school ribbon type cables, and we moved away from FFC cables. FFC cables are those thin white cables you've seen in a lot of consumer products. They're very low cost and they're very effective, but they do tend to come out sometimes, and we've had issues with that. And many companies don't like those kind of cables in their products. So we got rid of them. That makes the product simpler, more reliable, a little bit more expensive to do it this way, but it's better for you, and that's what matters to us. So we've mounted them in. We use grabbers to hold the cables in place so they don't shock and move out of the connectors when they get shipped or banged around on your bench. And that's all important stuff. So overall, we kept the design really dense, really low power, really quiet. Low heat causes less drift, as I mentioned before, and really a very compact, elegant design that allows you to achieve the small size. So when you're all done, you got something like this that can fit anywhere you want it to on your bench. The microprocessor control makes it easy to use on the front panel, and overall, it's a great little power supply for your bench. So you can power forward with the E36100. So in conclusion, thank you for attending this video. I hope you enjoyed it, and hopefully in the future we can do more teardowns and show you what we've done inside so you can better appreciate what our products can do for you today. Thank you.